So in lecture 2 of the application of different forms of energy, we are going to take the topic of thermal energy. Okay, so we are going to talk about thermal energy, which are the ways in which it can be stored and what are the different storage mechanisms that we have. So usually speaking, there are basically 4 different thermal energy storage system. Okay, and the first one is sensible heat storage, and we are going to take each of them one by one. So an objective question might be how many types of thermal storage energy systems are there, and you could just name these 4. Okay, maximum of 2 marks. Next we have got the molten salt thermal energy storage. So as you can understand the term molten salt, so we are using a very high temperature to melt the salt, in fact, to store the energy. And then we have got the seasonal thermal energy storage, which is kind of different from the other two. Okay, and then we have got the latent heat storage. So at the first instant you might think that the latent heat storage and the sensible heat storage more or less sounds the same, but as we go along I'll tell you what's the difference here. Okay, so first let's take up the sensible heat storage. Now this sensible heat storage is the most commonly used form of thermal energy storage. So it's the most popular one, it's in fact the cheapest one. Okay, it's mostly used, and by the term sensible it comes from the word sense. Okay, so if you can basically sense the heat or feel the heat, okay, you are doing something which is called a sensible heat storage, and it describes the thermal energy that changes a material's temperature. For example, warming water. So if you basically take a thermos flask, and what you are doing is you are storing the heat. Okay, you heat up some water and put it into the thermos flask, and you know that the flask is going to remain maintain its temperature till the end of the day. Okay, and that means you are storing that heat in the warm water. Okay, in water. So water is basically the storage mechanism, along with of course the enclosure of the thermos. So this is the exact thing that we are talking about here. Okay, and then in this kind of thermal storage, what will be the storage medium? So as I told you, water, but we can also use something which is the molten salt, air, sand, gravel, rocks, and so on. Okay, so a molten salt heat storage system is something similar like a sensible heat storage system, but there we only use the salt. Okay, here we can use different sources. So what happens, the storage medium is heated or cooled to use the stored heat or cold later. So if you consider a heat storage, it doesn't mean that we are only storing temperature, we can also store a lower temperature. Okay, so that it can be used in summer, heat can be stored so that it can be used in winter, and vice versa. Okay, and so on. So in some application this involves the surplus thermal energy. So from where we are actually getting the thermal energy is the sun, of course. Okay, enormous amount of energy, but we are not able to tap into all of the types of energy that is possible. So this is one way of tapping the energy, sun's energy. Then we have got the geothermal activity. As I've told you in the previous classes, the geothermal energy is something which cannot be obtained from anywhere, any location. It's geographically restricted. And then we have got the waste heat from the industrial process. So the heat that is generated in the industrial process, maybe from the chimneys or the exhaust pipes, can be used and stored so that they can be used later. Okay, what we can do actually is in fact use this heat to even generate electricity. So if you think about the power plants which need steam, we need heat to steam it up, to make the steam, right? So that heat can be actually used from this sensible heat storage. So what happens is electricity is used when it is inexpensive to store energy for use at peak times. Okay, so if you cannot store the energy at a reasonable cost, you better prefer using the electricity. Okay, next we have got the molten salt thermal energy storage. So salt usually melts at 131 degrees centigrade. Okay, and it melts at 131, but it is heated by 566 degrees centigrade. Okay, so that means it has far crossed its molten level. Okay, and then it is stored, and that is what is the molten salt thermal energy storage is. Okay, so it basically is stored. Okay, the solar thermal energy, it can be stored at extremely high temperature using the molten salt. Okay, so what we do is we use a concentrated solar power. So what happens is we do have some set up something like this, which looks like a dish, and then and then the sunlight basically falls on this and it gets concentrated. Okay, so sorry. Okay, so what happens is the sunlight basically falls and it gets concentrated. Okay, so if we just take this, okay, so it will fall at different locations and finally it will get concentrated and heat up at particular location, and then this location will have the salt which will actually get heated up. Now then this heated salt or the molten salt is stored in a insulated tank. Okay, which is similar to something like a thermos flask when we talk about the water storage. Okay, so the thermal energy can be stored here up to for a week, for a number of weeks. Okay, it doesn't have a very long time storage provision, but it can definitely be stored up to some weeks, even for a month or two. The high temperature of the molten salt can be used to superheat steam. So we know the heating process in power plants, and then this can be used to superheat that steam, and then that steam can power the turbine, and then we can actually generate the electricity. Okay, so that is why this is important to know. Then we have got the seasonal thermal storage. So most of these heat storage, what they do is they are storing the heat for a definite period of time. But if we talk about seasonal, it means that if I am storing heat in the summer, I am able to use it in winter, or I am storing something which is cold at in the winter, I should be able to use it in summer. Okay, so this is what we need, and that is what is seasonal thermal energy storage is all about. So basically many applications of sensible heat storage store thermal energy to release in just hours later. So I store it, I use it within an hour, within the day. Okay, in several cases heat is stored for days, weeks and even months. So it becomes months, then we are talking about more of a seasonal system. So in an experimental solar community in Alberta, Canada, they have done this experiment. Okay, what they did is they produced heat by solar collector in summer and stored in giant water filled boreholes underground. So you know sand is not a bad insulator, it's quite a good insulator. So if they store it underground, the chances of the heat getting out is much lesser. Okay, apart from some obviously specially devised instrument. And then months later, when it is very cold in the northern winters, okay, Canada usually has got a very cold temperature during winters. This thermal energy can actually be used to heat the community. So basically the region wise heating can be done using this system. A similar setup was also used in Vogens in Denmark, which uses the same setup. Okay, which stores the summer heat in an enormous thermal pit storage tank. So they have a thermal storage pit storage tank. So what you can see from here that these things are practically applicable, and in fact some countries are already using these kind of technology. Next is something which is called the latent heat storage. Now this latent heat storage has got some advantages over the sensible heat storage, but this is still not practically used. This is still in the research phase. So what happens is when sensible heat involves the simple heating, okay, simple heating or cooling of a material, but in latent heat there is a change in phase of the material. So if you heat a system so much that it basically transfers from solid to liquid or vice versa, that is basically nothing but the latent heat storage. So the material that we use for the storage here is nothing but the phase change material, and in this phase change, by phase change we mean that it will transfer from one state to another. So it will be transferring from solid to liquid or liquid to solid and so on. Okay, so thermal energy is transferred to this phase change material as sensible heat until the transition temperature is reached. So what do you mean by transition temperature? The temperature at which it is on the brink of change of phase, the material changes its phase at that particular point. So what happens is all the thermal energy goes in changing the phase, and the temperature remains constant until the material has completely transitioned. So the temperature will keep on remaining constant, the material will keep on absorbing heat, and solid will change to liquid. Then what happens as the material cools down, this changes back into the solid and the latent heat is released. So if I am cooling down the material, let's say is converted into liquid, and liquid again gets back into solid, there should be a release of heat, and that release of heat is actually used. So this is the latent heat storage. Now this is actually a costly affair because sensible heat is far cheaper from the thermal energy storage. However, what happens, latent heat offers energy density almost 3 times as high. That means the amount of heat that a sensible heat storage system can store is 3 times lesser compared to latent heat storage. So latent heat storage can store more heat, but then this kind of system has not been yet adopted commercially, and research and development is still in progress. So what are the benefits of this thermal energy storage for the power grid? So most of the times these heat storage are used for generating electricity on a larger scale. Of course, on a smaller scale we use the thermos flask for having warm water and so on. But in general, the more important aim is from a commercial point of view is to generate electricity. So there are two key ways that store thermal energy benefits in grid as a whole. Okay, what happens is by using excess thermal energy for heating and cooling needs, this removes a significant electrical load from the grid. So if we have a system, so this is a separate use from using it in electricity. If we have some community, some region where you need to heat it up during winter or cool down the temperature during summer, then you use a lot of electricity. Now in order to lessen that effect on the electrical grid or lessen the load on the electric grid, what we do is we can use this thermal energy storage system. This will actually reduce the demand of the grid, because air conditioning uses a lot of electricity. So if you consider a heating system like a normal room heater, or if you use a cooling system like air conditioning system, this uses a lot of electricity. So if we can replace that power need by something else like a energy storage system, that will definitely reduce the load on the grid. So this is basically sensible heat transfer is one of the cheapest form of energy storage available. So then the second way is to generate thermal energy to directly generate electricity. As we've seen in thermal power plants, this electricity is basically generated by moving the turbine with the help of steam. So we can use that thermal energy to generate that steam, and mostly molten salt technology can be used. So while battery energy storage systems are ideal for quick burst of power to smooth out fluctuations in supply, molten salt systems can retain vast quantity of heat for days. These systems can be used for base load generation. So you can use a hybrid system where you have the thermal energy storage system attached, the molten salt energy system attached, you have a battery attached, you have the power grid. All of them can be combined together to make a hybrid system to get an uninterrupted power supply. That's always possible. So finally, when the equipment necessary for molten state energy storage is specialized, thermal storage typically uses abundant non-toxic and cheap materials, making it a cost-effective way of storing energy. So basically consider something like sensible thermal energy storage that will definitely be much cheaper compared to the other techniques that we have already mentioned. So if you look into a typical block diagram of this, or how does it work, it is something like this. You basically charge, that means you are going to put the heat into the thermal energy storage, and that heat source might be solar energy, that might be electricity, or that might be any other source of heat like the geothermal energy and so on. And then what will happen, this will be the fluid, there will be a fluid which transfers the heat. So you can have water, might be a fluid, and it will transfer the heat, that is basically termed as HTF, into the system. And then when there is a need, let's say in winter we are using, or we are using it some hours later, we can extract that same thermal energy and then use it in the system. So that system is basically nothing but called, I hope you have heard about the term sink and source. So source is from where the heat is generated, sink is where it is, in this case where it is used. So it might be a heat engine, it might be a process steam, it might be a district heating, it might be an absorption chiller and so on. So this thermal energy storage might be in the form of heat or in the form of cold. You have to just remember this. And then you can use this heat transfer pump to actually pump the extracted heat from here and back there. That is also possible. So these are some of the systems that we are using. So this is basically a very general block diagram. So that's all for today. So I hope this has helped you, and please remember, we are also going to have some objective questions from this part possible. Thank you.